Hello everyone, uh, welcome to my YouTube channel. My name is Amit, and today uh, we are going to discuss the problem apple tree. So let's read the problem. Time of has an apple tree growing in his garden. It is rooted tree of n vertices with a root in vertex 1. A tree is a connected graph without loop and multiple edges. This tree is usually unusual. It grows with its roots upward. However, it's quite normal for a programmer's tree. The tree is quite young, so only two apples will grow on it. Apples will grow in certain vertices. Maybe they are same. After the apples grow, the time socket starts shaking the tree until the apples falls. Each time socket shakes the tree, the following happens to each of the apple. Let the apple now be at vertex U. So if the vertex U has a child, the apple moves to the child. If they're having multiple childs, they can move to any of them, and otherwise the apple falls from the tree. So in it can be shown that there are after a finite number of times both the apples fall from the tree. The times of E has few assumptions in which vertex apple can grow. He assumes that apples can grow in vertex X and Y, and he wants to know the number of pairs A, B from which the apples can fall. And the vertex from which the apple from vertex X will fall to B, and the vertex from which X is is A and respectively. Help them to find. So let's understand the problem. So basically, I having a rooted tree which is uprooted means it's going down and down. So it's start with one I mean root. So let us say it's let us take an example. So yeah, so let us say this is my uprooted tree, right? And we having a tree, and they give me a assumption means a position where there are two apples. There can be two apples only. So let us say the apples present. One apple is here. Let us say it is A, and one apple is here. B. It is called B. So we have to calculate the total number of vertices x comma y from which apple A can fall, or from y the apple B can fall, right? So the apple, and if we are at any vertex U and it's having a child, it's having some childs or one child, so it's moved to its child in its child, or if it is on the leaf nodes, it's fall up. So for this, let us say A go to 2, and then E go to 3 because he having only one child. So from 3 he having two possibilities. Either he can go to right or left. Same goes for B. B has two. He go to 3, and then he having two possibilities that he can either go to 4 or 5. Right. So there are total four possibilities. Two for B. There are two possibilities for A, and there are two possibilities for B. So we have a total of four possibilities for A and B. So how can we solve this? So for solving this, we just have to make a uh, make a possibility array which stores the possibility from a given vertex. How we can there how many possibilities from a given vertex. So let's take another tree. So let us say we are in a tree 1, 2, 3, and this is 4, and we are in 5, right? So uh, let us say I am talking about my apples are at 1 and 2. So there are how many possibilities for? So in this I have to calculate the possibility for vertex A, B for every vertex because there are few queries in which he assume that the apples are at these vertex A and B. It can be anything. So let's build the solution for this. We know for the we have to build a solution for this for every node. So I can build this using a recursive approach in which I build the recursion from the leaf nodes till every node. So uh, we know Apple, there are two possibilities. Apple either go from this leaf node or this leaf node, and from any other leaf node it can't go. So I make a recursive call for, I start from one. So I make a recursive call for two. There are from one there is should be only one possibility. It can be go to two. From two there are two possibilities. Either he can go to three, right? Or either he can go to four. So let us say, let's assume we go to four. And when we go to four, there is only one possibility, he go to five. So now he is in leaf node. From leaf node, he can't go to anything, anywhere. He just follow up the apple, right? So I know from this, there should be only one possibility. So in this case, I return one, which store the possibility from that node. So I return one, and then I know from four there should be only one possibility because only one uh, element. This is returning one, so this also returns one. So from four I go to two. So there should be a recursive call for three. So I know three is a leaf node, so it's basically it basically from that node the leaf should be fall, the apple should be fall. So the apple should be fall, so I have to return one because there should be a one possibility. So from four this there should be only there should be one possibility, and from three there should be only one possibility. There should be a possibility of one. So both from both sides they are having a possibility which having sum equals to two, because from two I know there are two possibilities. So we calculate for two. So for same as for one, it's calculated for mm, we calculate the possibilities as two. And when we count, we if I want to find for one and four, I know from one there are two possibilities, and from four there should be only one possibility. So there are two possibilities from which we can follow our apples, because from four it can only fall from five, and if it is in one, it can either go to five or either go to three. So that's why there are two possibilities. So in this question, we have to just build a recursive solution in which we return one when we found a leaf node, right? When we found out for a leaf node, I return basically one and store my count, which stores the number of possibilities for every node. So let's see the solution for this. So we basically take the integer n, and then we take a adjacency list which stores u comma v as its as is between u comma v, and then I push it in the adjacency list. Then I make a weighted array and a leaf node. These leaf stores the number of possibilities from every node. Then I take a we call for DFS from one because here the root node is one. So I store a count which counts the total number of possibilities at any node, and then I make a uh, I check the access from a given node, and if it is not in counter earlier, I may increase the counter and make a recursive call for uh, its child and store it in count, and finally I store the total count for every node in leaf node. And I know for every node the count should be minimum should be one, so that's why I make the maximum of take the maximum of the count and one, and then I finally I having leaf with some values in the possibilities from every leaf. So I just multiply these two for uh, the possibilities from every node. So for such more content, like and subscribe to our channel and share with your friends. So thank you. I hope you enjoyed this video.